Alright, this is section 2.7, combining of functions. There's two types of functions that we'll be combining in here. This one's real basic, and then this one's more complicated. The first one is talking about the four basic operations of adding, subtracting, multiplying, and dividing. So f plus g of x is just f of x plus g of x. You just add them together. F subtract g of x is just f of x minus g of x. You just subtract them. F times g of x is just f of x times g of x. And then f over g of x is f divided by g. Now the domain of this guy is the domain of the two functions intersecting. Whatever the two domains are, you just intersect them and that's your answer. Same thing here, same thing here. This one, it's the intersection, but you got to throw out where function g is equal to 0. You can't divide by 0. Now these last ones are a little confusing. It's called composite functions. This 0 is written smaller, almost like a degree sign, but it's written halfway up. Halfway up as high as, it's not as high as the top or the bottom, it's halfway between there. So f circle g, or f composite g of x, is f of g of x. So what you're doing is you're taking one function and throwing it into another. Now an example of that would be, you could take an example of two functions and combine them. You could say, I'm going to take my money and buy food at McDonald's. That's one function. Okay, then I'm going to eat the food, and then that's going to give me energy to play soccer. Now basically by combining the two functions, you're taking money and allowing it to play soccer, because the money changes to food, the food changes to energy to play soccer. So one function within another function. Alright, so then you got g circle f, which is g of f. F circle f is f of f. And g circle g is g of g. Now you'll see the hardest ones are even f circle g circle h, which is f of g of h. Now to find the domain of f circle g of x is you find the domain of f, you find the domain of g, and you exclude those inputs x that are from g, for which g is not in the domain of f. The resulting set is your domain of f circle g. In other words, start with the x values in your domain of g. Find what the range is for g. Now that range for g is now your input for f. Look at those inputs for f and make sure that they're acceptable for the function f. You're watching out for fractions or even roots. Those are typically your only problems when you're talking about domain problems. Alright, so 2.7, question 1, they give you a graph, but all you need to know from this question is that f of 2 equals 3 and g of 2 equals 5. So they first ask you, what's f plus g of 2? Well, that's f of 2 plus g of 2. Okay? And f of 2 is 3, g of 2 is 5, so 3 plus 5 is 8. F subtract g of 2 is f of 2 subtract g of 2. Well, that's 3 subtract 5, or negative 2. F times g of 2 is f of 2 times g of 2, which is 3 times 5, or 15. And f over g of 2 is f of 2 divided by g of 2, which is 3 over 5, or 3/5. Question number 2 says, by definition, f circle g of x is f of g of x. And then they say, so if g of 2 equals 5 and f of 5 equals 12, then f circle g of 2 is f of g of 2. But what's g of 2? We know g of 2 is 5, so you can replace the inside with a 5. And then f of 5 we know is 12. So f of g of 2 is 12. Number 3, if one of them, the rule is add 1 and then multiply by 2, or multiply by 2 and add 1. So f is take a number and you add 1. G is take a number and multiply by 2. So it's f circle g, that's f of g. And what's g? Replace the inside with a 2x. And now f says whatever you got, you're going to add 1 to it. So we got a 2x and we're going to add 1 to it. So there we go. That's f of g of x is 2x plus 1. Now what's g of f? Well, that's g of f of x. And you always work from the inside out. So what's f? We know it's x plus 1. And now what's g? G says whatever you got, you multiply it by 2. So take this guy and multiply by 2. And there you go. So where this one says multiply by 2 and add 1, this one says add 1 and multiply by 2. And that makes sense because they're opposite composite functions. The function f plus g of x is defined for all values of x that are in the domains of both f and g. The function f times g of x is defined for all values of x that are in the domains of both f and g. The function f divided by g is defined for all x that are in the domains of both f and g, and g of x is not equal to 0. When you're doing dividing, you got to worry about dividing by 0. Number 6. The composite function f circle g is defined for all values of x for which x is in the domain of g and g is in the domain of f. Alright. Question 8. They give you two functions and ask you to find f plus g, f subtract g, f times g, and f divided by g, and find their domains. So remember, f says f of blank equals 3 minus 2 times blank. And g says g of blank equals 2 times blank plus 1. So f says whatever you got, you say 3 minus 2 times it. G says whatever you got, you say 2 times it plus 1. So f plus g of x is just f plus g. F is 3 minus 2x and g is 2x plus 1. Add them together and you just get 4. Now what's the domain? The domain is the intersection of both functions. Well, a line has a domain of everything. A line has a domain of everything, so their intersection is everything. F subtract g is 3 subtract 2x subtract 2x plus 1. When you distribute that negative sign and simplify, you just get this. And again, the domain is the same thing. It's everything. F times g is f and g multiplied together. You're going to get quadratic. And again, the domain is everything. Now, f divided by g of x is the f function divided by the g function. But you remember, you got to throw out places where you're dividing by 0, so we're going to throw out minus 1/2. Set this equal to 0 and solve, and you'll get negative 1/2, and that's what you have to throw out. Question 15, they give you the same question. They give you two functions that are fractions. Okay, f plus g of x is 1 over x plus 1 plus 3 over x minus 2. You multiply each one by the other's denominator so you can combine them and simplify. And now notice you got to throw out a minus 1 and a positive 2 because you can't divide by 0. F subtract g is the same thing but subtraction. Again, you got to find a common denominator and simplify, and you got to throw out the minus 1 and the positive 2. F times g is f times g, which gives you this, and again you throw out the minus 1 and the positive 2. Now f divided by g, you got a fraction within a fraction, so you got a complex fraction here. So you get 1 over x plus 1 and 3 over x minus 2. You can invert and multiply, and you get x minus 2 on the top and 3 times x plus 1 on the bottom, or 3x plus 3 on the bottom. Again, you're going to throw out the minus 1 and the positive 2 because of division by 0. 19 says find the domain of the function. So here's your function, x minus 3 in parentheses to the negative 1/4. Well, a negative exponent means you cross the fraction bar with it and make it positive. And a fractional exponent of 1/4 is the 4th root. So we're looking at 1 over the 4th root of x minus 3. So what's underneath here has to be greater than or equal to 0, so that's 3 or larger. But you can't have it equal 3 because you'd be dividing by 0, so it's strictly greater than 3, or 3 to infinity. 20, you got the same problem here. You got to force x plus 3 to be greater than or equal to 0, so that's x is greater than or equal to negative 3. But you also have to worry about x equaling 1, so you got to throw out 1. So greater than or equal to minus 3, but not including 1. Okay, now 21 asks you to do what's called graphical addition. They give you f here, and they give you g here. G starts here at 0, 2, and it goes up and over here. Alright, so now they ask you to find what's f plus g. Well, you don't need to know what each function is. You can just add the y coordinates to get your new function. So here's 1, and g is 2. Well, 1 plus 2 is 3, so you plot 3. Here is 0, and here's 4, and 0 plus 4 is 4. Here you got minus 1, and you got 4, and so 4 minus 1 is 3. And then over here you got minus 2, and you get positive 2, and when you add them together you get 0. And so now when you connect the dots, that's what f plus g looks like. What you've done is you just added the y coordinates to get the new function f plus g. 24 is going to do the same thing. 24 starts with square root of x there, and x squared there. Now notice they're both above the x-axis, so when you add them, it's going to be even higher than both of them. So 0, 0 is 0, and 1 plus 1 is 2, and then 1.5 you get 1.1 plus 2 something, so it's even higher and higher and higher, and so there's your f plus g. 27, they want you to find f of g of 1 and g of f of 1. So they give you your original functions here. So f of g of 1 is you got to find what g of 1 is. G of 1 is just 1 squared plus 2, or 1 squared plus 2, which is 3. And to find f of 3, just plug a 3 into f, which is 4 times 3 plus 5, or 12. G of f of 1, again, you work from the inside out. Find out what f of 1 is. Plug a 1 in for f. That's 4 times 1 plus 5 is 9. And so then find g of 9. You plug a 9 in there and you get 83. 29, same idea. Same two functions, but they ask you to find f of g of negative 2 and g of f of negative 1. So f circle g of negative 2 is f of g of negative 2. You got to find out g of negative 2. So plug a negative 2 in there and add 2, and you get 6. And then f of 6, you plug a 6 into f and you get 29. G of f of negative 1 is g of f of negative 1. You plug a negative 1 in for f and you get 4 times minus 1 plus 5, which is 1. And then g of 1 is just plug a 1 in for g and you get 1 squared plus 2, which is 3.